everybody. Just in the last couple of clicks away from starting our video. What we're looking at in this video is section 2.2, where we're looking at angles formed by parallel lines. This is actually part 2. And so we're taking a look at the second part of what was expected in this particular lesson, where we're proving the properties of angles formed by parallel lines in a transversal. In the first one, we took some time to figure out what the relationships were for the properties of angles. And now I want to take a look at how we go about proving that to be true in mathematics. The vocabulary is consistent. We're still talking about alternate interior angles, alternate exterior angles, and consecutive interior angles. Now, what I want to look at today is to begin to explore this whole idea of what we do when we're trying to prove something is true. Now, we did learn in our previous unit about inductive reasoning and deductive reasoning. We learned that inductive reasoning allows us to find examples of things and to begin to form a hunch about what might be true. And we can gather all kinds of examples, but if we really wanted to know how to prove something, we had to do it deductively, and we used a variety of different ways to do that. And so basically, I want to just remind us of what does it mean when we say we're proving something is true. So let's go back. It really comes down to it that if we're trying to prove something is true, we have to quote something that is a law, or is a theorem, or is something that nobody disputes, all right? So let's take a look at some regular everyday examples. If an apple falls from a tree, you and I know if that apple falls from the tree, it's going to drop to the ground. But the question I have for you is why? Why do we know that that's going to happen? Well, we know that's going to happen because of the law of gravity. We know that our Earth operates with this pull towards the center of the planet, and we call it gravity. Well, how about this one? If someone commits a serious crime in our society, we know that it is likely that that person will go to jail. If they're found to be guilty of a serious crime, they go to jail. Well, the question is why? Because it's the law of the way we interact as a society. If you kick a soccer ball, and you watch the pattern of the way that soccer ball goes, you know that it's going to create this lovely path of a parabolic curve. Why does that happen? Well, once again, that's the law of gravity has created this. We know this is going to happen. If someone starves themselves, we know because of the law of the way our bodies work that that person, if they don't eat, will eventually lose weight, and eventually actually they would end their life because we cannot survive without it. So the question is, that's the way our bodies work. That's the law of how things work. So now let's take a look at how this works then with some angles of parallel lines. It's a bit of a jump, isn't it, to go from real life to the angles of parallel lines, but there you have it. So if I have a parallel line with a transversal, can you make a conjecture about the relationship of the alternate interior angles? Well, from last class, you know that alternate interior angles are equal. Now you will recall that we went through an example like this one, but I want to be able to actually write this down and prove this deductively so that nobody can ever argue with me that alternate interior angles are equal. So I'm going to use that same illustration we had in the last video. Remember where we said angle E and angle H were the same because they were opposite angles or verticate angles. And then we knew that H and D were the same because they were corresponding angles. And that showed us, hey, these two angles are the same, so alternate interior angles are the same. Well, all that remains is for me to put this into writing, and this proves it for me deductively. I'm using what we call a two-column proof, where you start with a statement, and what you give as a proof is the law or the rule that you know, like we did with the other statements. And I'm just going to write it down. I'm going to say the measure of angle E is the same as the measure of angle H. The reason I know that is because they're vertical angles. And then I know that the measure of angle H is the same as the measure of angle D. I know that because they're corresponding angles. The last step is to say that the measure of angle E is the same as the measure of angle D. And here we're using something we call transitive property. If this is equal to that and that is equal to this, then this is equal to this. This is what we call the transitive property. And so, in other words, we have just proven deductively that alternate interior angles are equal. Now, just so you know, at this stage in mathematics, we're not going to ask you to create this proof by yourself, but we are going to ask you to give us the reasoning for something. So I will give you things like this on the side, and I want you to be able to list for me what the reasons are that you can say these things. And so it's a bit of a sort of beginning proof writing. All right, let's take a look at the next one. If you have parallel lines with a transversal, can you make a conjecture about the relationship of alternate exterior angles? Well, we know from the diagram that we used to be true that alternate exterior angles are also equal. We used it. These guys were vertical, these guys were corresponding, these ones were vertical, so we knew that this one and this one were the same. So let's write it down. We know that alternate exterior angles are equal, and let's put it into writing so we prove it deductively. Here it goes. Measure of angle E is equal to the measure of angle H because they're vertical angles. Measure of angle H is the same as the measure of angle D because they're corresponding angles. The measure of angle D is the same as the measure of angle A because they're vertical angles. And then we put it all together because all of these things, this is equal to that is equal to this is equal to this, that. So these guys have to be the same. We call that the transitive property. It's a wonderful property. Measure of angle H and the measure of angle A, these little guys that are in here, are actually equal to one another. In other words, the alternate exterior angles are equal. Okay, last one. If you have parallel lines with a transversal, can you make a conjecture about the relationship of consecutive interior angles? Well, we know from what we learned from before that consecutive or co-interior angles, we also call them, are supplementary. We are going to prove this deductively, and we're going to use that diagram that we had from before, what we knew to be true. So let's put it into writing deductively. All right. Well, we know that angle F, the measure of angle F plus the measure of angle H, are going to equal 180. We know this because they are a linear pair. We know that angle H is the same as angle D because they're corresponding angles. So therefore, because I know that H and D are the same, I can substitute D into this one. So the measure of angle F plus the measure of angle D now is 180 degrees. Substitution. In other words, these two angles, the consecutive interior angles, are supplementary. All right, so we do have a couple of questions here where to show you the kinds of things that we ask you to do in this part of the section. So we ask you to find angle A, B, C, and D. And so not only do we ask you to find them and tell us what they are, but we ask you to give the reasoning. So we know that angle A is the same as 110 because they're corresponding angles. So we say the measure of angle A is 110, and the reason is they're corresponding angles. B, we know that the measure of angle B is 110 because they're vertical angles. The next one, A and C. Now, if we take a look, this is a parallel line and so is this one. A and C are consecutive interior angles, so they will have to be supplementary. So that means the measure of angle C is 70 degrees because they're consecutive interior angles. And lastly, we know that angle D is the same as C because they're alternate interior angles, so the measure of angle D is also 70 degrees. Next one is a little bit closer to a proof. And what they have is a diagram. They say this is one side of a cell phone tower that we're looking at, and we want to use the angle measures that are given to prove that the braces are truly parallel. So we're looking at them, and if you look, we want to look at this is parallel to this, is parallel to that. Now, if you notice, you've got an angle right here and an angle right here. They're both 78, and since those are corresponding angles in the right position, since those angles are the same, then this bar has to be parallel to that one. And then if we look at this angle where I have a 35 and a 35, I can see, hey, those are alternate interior angles. And since they're the same, then that means that this has to be parallel to that. Let me put that in writing. So I used a simplified version of the diagram to help me. And here's where I read it. Now, this kind of proof, we did it from scratch in this particular lesson, but the kind of ones I'm going to give you are simply where I give you these bits of information and you give me the reasons. So let's pretend that these were given. So the measure of angle DCB, let's find it, DCG, it should be, sorry, DCG, all right, is equal to the measure of angle BAE. Here he is, given to us. That's how we knew it. It was in the diagram. Therefore, this line CG is parallel to AE, and the reason that that is that these corresponding angles are equal. Then we go on to the next one, angle CGB, so this little 35 is the same as GBF, this little guy, and that is given to us on our diagram. And since those are equal, then this line CG is parallel to this one, BF, and the reason is that alternate interior angles are equal. So in other words, if we put this all together, and really I could have put this directly in the proof, I could have said at the bottom, therefore, CG is parallel to AE is parallel to BF, and the reason is transitive property, or you could say substitution, but we have proven that all of those lines are parallel. All right, everybody, that was our objective, to prove the properties of angles formed by parallel lines in a transversal. The homework for this one, there was a worksheet that I gave to you, which gave you a chance to practice finding the angles and giving your reasoning, and then 2 questions from your textbook. Good luck, everybody, with your work, and make sure you bring questions that you have to class.